It's an invisible force that can cool you down on a hot day or, tear the roof right off a house. We feel it every single day, but what is wind, really? And what powers this massive planet-wide engine? Okay, let's dive right in and unpack the secrets behind our planet's winds. It seems like such a simple question, doesn't it? But the answer? Well, it's all about this constant, invisible battle that's happening all around us. A battle governed by one fundamental force. And here it is, the hero of our whole story, air pressure. It's literally the weight of the air pushing down on you. I know you don't feel it, but every column of air has mass, and it's always pushing. This weight, this pressure, it's the single most important ingredient for creating weather. So here's the crucial point, the one simple rule you gotta remember. Air hates being crowded. Just think of people in a packed room trying to get into an empty hallway. Air does the exact same thing. It will always, always flow from an area of high pressure to an area of low pressure. That movement, that rush to balance things out, that's what we call wind. Okay, that's a great start, but it leads to the next big question, right? If air is always trying to even itself out, what's creating these high and low pressure zones in the first place? What's messing with the balance? The answer, my friends, is the sun. See, our planet gets heated unevenly. And when air gets warm, its molecules spread out, it gets lighter, and it starts to rise. That leaves behind an area with less air pushing down, and boom, that's your low pressure zone. On the flip side, cold air is dense. Its molecules are all packed tightly together, so it sinks, creating a zone of high pressure. It's really that simple. Heat creates low pressure, cold creates high pressure. We actually see this principle in action every single time we go to the beach. During the day, the land heats up way faster than the sea, so the warm air over the land rises, creating low pressure. To fill that empty space, the cooler, denser air from over the sea, our high-pressure zone, rushes in, and that's your classic sea breeze. Then at night, the whole process reverses. The land cools down faster, creating high pressure, and it pushes the wind back out towards the warmer sea. It's like a perfect tiny weather engine. Now, that simple little engine of heating and cooling doesn't just happen at the beach. It happens on a planetary scale. So let's zoom out and see how this creates these massive, invisible belts of pressure that wrap around the entire globe. Just like the sun heats land and sea differently, it blasts the Earth's equator with way more intense heat than the poles. And that massive temperature difference is what drives the formation of these huge, stable bands of high and low pressure that circle the entire planet in a really predictable pattern. So here they are, the 7 big ones. You've got this intense low pressure at the super hot equator, an area early sailors called the doldrums because the winds there are so calm their ships would just get stuck for weeks. Then you have high pressure zones in the subtropics, which they called the horse latitudes, another calm spot where sailors sometimes had to, lighten their cargo. This whole alternating pattern of high and low pressure totally sets the stage for our planet's major wind systems. All right, so now that we have these giant zones of high and low pressure, we've got the fuel for massive permanent winds that are constantly flowing between them. Let's take a look at how they work. But wait a minute. If wind just wants to go from a high to a low, shouldn't it just be a straight shot? From the subtropics right down to the equator in a nice straight line? Well, it turns out it's not quite that simple. There's a pretty major twist in our story. And here's the twist. It's called the Coriolis effect. Think about it. As wind is traveling across the surface, the Earth is spinning underneath it. That rotation actually causes the wind's path to get deflected. So in the northern hemisphere, it gets pushed to the right, and down in the southern hemisphere, it gets pushed to the left. This is the invisible hand that turns what should be straight-line winds into these huge, curving global patterns. So when you combine the pressure belts pushing the air, and then you add the Coriolis effect bending its path, you get this, a complex but pretty predictable system of permanent winds. And these aren't just weather facts. These are the patterns that literally shaped human history, powering the age of exploration and creating the first global trade routes. And these patterns give us our 3 major permanent wind systems. You have these super reliable trade winds, and yeah, they were named that because they were the oceanic highways for centuries of commerce. Then there are the powerful westerlies that pretty much dictate the weather for places like Europe and North America. And finally, you've got the frigid polar easterlies coming down from the poles. Each one of them is a direct result of that epic battle between pressure and our planet's rotation. But, this whole system isn't always stable and predictable. Sometimes the differences in pressure become incredibly intense. And, well, that's when things can get really wild. This is a cyclone. It's basically a low-pressure zone on steroids. The pressure in the center becomes so ridiculously low that air comes screaming in from all sides at tremendous speeds. And because of our friend the Coriolis effect, that inward rushing air begins to spin, creating that iconic spiral shape of a hurricane or a typhoon. So let's peek under the hood of this storm. Warm, moist air gets sucked in at the surface, spirals violently upwards, and as it cools, it releases just enormous amounts of energy that fuel the whole system. And then right in the middle of all that complete and utter chaos is the calm, eerily quiet, low-pressure center we call the eye. Now, it's important to note that not all cyclones are created equal. You have tropical cyclones, like hurricanes. They're born over warm ocean water in the summer and are pretty compact, but just unbelievably violent. Then you have temperate cyclones. They form where huge warm and cold air masses collide. They're much, much larger, but generally their winds are a bit weaker, and you see them most often in the winter. And when these atmospheric forces become concentrated in the most extreme, terrifying way imaginable, you get this: a tornado. A violently rotating column of air that represents the most powerful and destructive winds on the entire planet. So let's just boil this all down, okay? 1. Wind is just air moving from a crowded place to an empty one, high to low pressure. 2. The sun heating our planet unevenly is what creates those crowded and empty spots. 3. The Earth's spin throws a curveball, bending the wind's path. And 4, when those low-pressure spots get really intense, you get a powerful spinning storm. That's the whole story. From a gentle breeze to a devastating hurricane, it's all part of the same incredible global engine, constantly working to find some kind of balance. And that leaves us with a really critical question for our time, doesn't it? As we keep changing the planet's temperature, how are we altering the fundamental rules of this invisible, life-giving force?